హలో స్టూడెంట్స్, ఈ వీడియోలో మనము టీఎస్ జెన్కో 2024 నోటిఫికేషన్లో మెకానికల్ ఇంజనీరింగ్ వాళ్ళకు అండ్ ఎలక్ట్రానిక్స్ ఇంజనీరింగ్ వాళ్ళకు బేసిక్ ఎలక్ట్రికల్ ఇంజనీరింగ్ అనే సబ్జెక్ట్ ఇచ్చారు. సో ఇది నాన్ కోర్ సబ్జెక్ట్ కాబట్టి సో ఎగ్జామ్ మనకు జూలై 14th రోజు ఎగ్జామ్ ఉంది కదా. సో ఈ ఎగ్జామ్ బిఫోరు ఈ సబ్జెక్ట్ క్విక్గా రివిజన్ చేసుకోవడానికి, షార్ట్ టైంలో కాన్సెప్ట్స్ అన్ని నేర్చుకొని బిట్స్ ప్రాక్టీస్ చేయడానికి ఒక 4-5 వీడియోస్ చేస్తాను. సో ఫస్ట్ ఈ వీడియోలో కాన్సెప్ట్స్, ఎవ్రీ టాపిక్ సంబంధించి కాన్సెప్ట్స్ అండ్ దాని రిలేటెడ్ ప్రాక్టీస్ క్వశ్చన్స్ అండ్ దాని రిలేటెడ్ పీవైక్యూస్ డిస్కస్ చేస్తాను. సో ఇది సిలబస్ మెకానికల్ వాళ్ళకు అండ్ ఈసీ వాళ్ళకు కొన్ని కామన్ సబ్జెక్ట్స్ ఉన్నాయి. సో ఇది మెకానికల్ వాళ్ళకి ఇచ్చినటువంటి సిలబస్ ఇది, అండ్ ఈసీ వాళ్ళకి ఇచ్చినటువంటి బేసిక్ ఎలక్ట్రికల్ ఇంజనీరింగ్ సిలబస్. సో ఈ రెండు సిలబస్ను కంబైన్ చేస్తూ సో ఈ నెక్స్ట్ 4-5 వీడియోస్లో ఏమేమి టాపిక్స్ డిస్కస్ చేస్తానంటే, నేను ఎలక్ట్రికల్ సర్క్యూట్ బేసిక్స్, ఓమ్స్ లా, కేవీఎల్ కేసీఎల్, రెసిస్టర్స్, ఇండక్టర్స్, కెపాసిటర్స్, సిరీస్ ప్యారల్ కనెక్ట్ అయినప్పుడు ఈక్వలెంట్ రెసిస్టెన్స్, ఇండక్టెన్స్, కెపాసిటెన్స్ ఫైండ్ అవుట్ చేయడము, అండ్ బేసిక్స్ ఆఫ్ ఎలక్ట్రోమాగ్నెటిజం, డీసీ జనరేటర్ అండ్ డీసీ మోటార్స్, ట్రాన్స్ఫార్మర్స్, నెక్స్ట్ 3-phase ఇండక్షన్ మోటార్ అండ్ సింగిల్ ఫేస్ ఇండక్షన్ మోటార్, ఆల్టర్నేటర్స్ అండ్ బేసిక్స్ ఆఫ్ ఇన్స్ట్రుమెంట్స్. ఈ 10 టాపిక్స్ కాన్సెప్ట్స్ అండ్ వాటి రిలేటెడ్ కొన్ని ప్రాక్టీస్ బిట్స్ అండ్ పీవైక్యూస్ డిస్కస్ చేశాను. ఫస్ట్ ఎవ్రీ టాపిక్ కాన్సెప్ట్ డిస్కస్ చేస్తాను. కాన్సెప్ట్ తర్వాత కొన్ని ప్రాక్టీస్ క్వశ్చన్స్ అండ్ ప్రాక్టీస్ క్వశ్చన్స్ తర్వాత దాని రిలేటెడ్ కొన్ని పీవైక్యూస్ డిస్కస్ చేద్దాము. ఇది ఈసీ అండ్ మెకానికల్ వాళ్ళకు నాన్ కోర్ సబ్జెక్ట్ కాబట్టి ఎవ్రీ కాన్సెప్ట్ కూడా ఇన్డెప్త్ అనాలిసిస్ కాకుండా మనము బేసిక్ కాన్సెప్ట్స్ మాత్రమే డిస్కస్ చేస్తాము. ఇంకోటి ఏంటంటే, ఎగ్జామ్ చాలా షార్ట్ టైంలో ఉంది కాబట్టి కాన్సెప్ట్ ఇన్డెప్త్ అనాలిసిస్ కాకుండా క్విక్గా ఎగ్జామ్ పాయింట్ ఆఫ్ వ్యూలో, స్ట్రిక్ట్గా ఎగ్జామ్ పాయింట్ ఆఫ్ వ్యూలో కాన్సెప్ట్ డిస్కస్ చేస్తాను. సో ఫస్ట్ ఈ వీడియో అనేది ఇంగ్లీష్ అండ్ తెలుగులో ఉంటుంది. So let us start with our first concept, that is current. We all know current is nothing but flow of free charge carriers. Current is nothing but what? Flow of free electrons. Flow of free electrons or flow of free charge carriers is known as what? Current. Free charge carriers. Current is denoted with I, and current I is equal to charge Q divided by time. And current is also defined as rate of change of charge. Rate of change of charge. Rate of change of charge is also known as what? Current. See, if rate of change of charge is not uniform, if the charge is not changing with respect to time in a not uniform manner, then current I is equal to dq by dt. What is the unit of current? Current unit is nothing but what? Amperes. Now let us discuss about the current direction, which is very, very important. Here I have taken one copper strip. It has some free electrons. You see, these negatively charged particles are free electrons, and this copper strip is connected to some battery, and as electrons are negatively charged particles, this positive terminal will start attracting the electrons. Then all the electrons will start moving towards the positive terminal, and this negative terminal will repel the electrons. So from negative terminal there is a repulsion force onto the electrons, and from positive terminal again this positive terminal is attracting the electrons towards the positive terminal. Then electrons will start moving from negative terminal to positive terminal. So electrons are moving from negative terminal to positive terminal. So as we know, flow of electrons is nothing but what? Current. So from this the current direction is from negative terminal to positive terminal. But usually we take current direction is from positive terminal to negative terminal. Why like that means, before this electron theory was invented, scientists used to think that current will be flowing from higher potential to lower potential. This is high potential and this is low potential. Current is flowing from higher potential to lower potential. Even after the electron theory invented, and we came to know that current is not flowing from positive terminal to negative terminal, current is flowing from negative terminal to positive terminal, still we are following the old convention. That is the reason we call conventional current direction. Conventional current direction. Conventional current direction is from positive terminal to negative terminal. Conventional current direction is from positive terminal to negative terminal. But electrons flow are negatively charged carriers direction is from negative terminal to electrons flow direction is from negative terminal to positive terminal. If I take positively charged carriers direction, it flows from positive terminal to negative terminal. So whenever we are analyzing the circuits also, we follow conventional current direction, that is from positive terminal to negative terminal. Now let us see how much current is known as 1 ampere of current. We know current is equal to I is equal to charge by time, I is equal to Q by T. So I want to get 1 ampere here. So in place of charge I have taken 1 coulomb, and in place of time I have taken 1 second. So 1 coulomb per second. We know 1 coulomb of charge is nothing but what? 6.24 into 10 power 18 electrons charge is known as what? 1 coulomb. So if 6.24 into 10 power 18 electrons are flowing in 1 second, and it will result into 1 ampere of current. So 1 ampere of current means how much? Whenever 6.24 into 10 power 18 electrons are flowing in 1 second, that will result into 1 ampere of current. It is very, very important. So this is about the current. Now let us see one more important concept, that is one more basic important concept, that is nothing but what? Electric potential. Electric potential. Electric potential we denote with V. So what is the meaning of electric potential? Let us say one body is there. Let us say body, this is A. To charge this body, either we have to remove the electrons or we have to add the electrons. So to charge this body, we have to do some work. So whatever the work we have done to charge this body, that stores as a electric potential in the body. Or let us say one charged body I have taken, and it can repel the negative charged particle, it can repel the negatively charged particle, or it can attract the it can repel the positively charged particles, and it can attract the negatively charged particles. Because of its charge, it is able to attract, or it is able to repel. So it is able to do some work. So capacity of the charged body to do some work is also known as electric potential. So capacity of the charged body to do some work is known as what? Electric potential. So electric potential V is equal to, what is the formula? W divided by Q. Work done to charge the body to Q coulomb. So what is the units of electric potential? Volts. And one more unit is from this formula. Work is nothing but what? Joule. Charge is nothing but what? Coulomb. Joule per coulomb is also one more unit for electric potential. And here one more important formula, that is, let us say Q is a positively charged body, and there is one point A which is d distance away from Q, and what is the electric potential at point A is Q divided by 4 pi epsilon d. So as the distance increases, electric potential is going to decrease. As the difference decreases, electric potential is going to increase. So V is directly proportional to 1 by d. Now what is the meaning of potential difference? Let us say one point A is at 5 volts potential and point B is at 3 volts potential. what is the potential difference between point A and point B is this 5 volts minus 3 volts. So you see 5 volts when compared to 3 volts, 5 volts is a high potential that I am treating as positive terminal, and plus 3 volts has less potential when compared to plus 5 volts, then this I am treating as negative potential. So this is negative terminal now, this is positive terminal. As we know, electrons will be flowing from negative terminal to positive terminal. Now let us see what is the EMF. Very important concept, EMF. So EMF is like a force, it will causes the flow of electrons. So EMF, so whenever we have battery, like this, positive terminal and negative terminal, so some potential difference is there. Because of this potential difference, the current will start flowing in the circuit. So this potential difference will be maintained by EMF. So EMF causes the potential difference, and potential difference will cause the flow of electrons. We say the energy given to each coulomb of battery is due to the chemical action. This potential difference is created due to the chemical action. Now see what is the relation between power, voltage and current. We know that power is nothing but rate of change of work is known as what power. Power is equal to dW by dt. So numerator and denominator I am multiplying with dq, dW by dt into dq by dq. So this dq is coming over here, and dt, dW by dq into dq by dt. We know W by q is nothing but what? Potential, voltage. Charge by time is nothing but what? Current, voltage into current. Very important formula for power is voltage into current. P is equal to V into I. And you see here P is equal to V into I, and according to Ohm's law, V is equal to what? IR. So V is equal to IR into I, that is I square R. One formula for power is P is equal to I square R. And in place of I am substituting V by R. P is equal to V into I. V into I is equal to V by R, that is nothing but what? V square by R. So three formulas for power, very important formulas. P is equal to Vi, and that is equal to I square R. In terms of voltage, it is what? V square by R. And next, what is the let us see what is the electrical energy. So energy is equal to what? Power into time. Power is nothing but what? Voltage into current into time. So if we convert into voltage terms, V square by R into T. If we convert into current terms, it is I square R into T. So usually in our household, the energy meter will be there. We tell like some 100 units of energy. 100 units of energy is nothing but that 1 unit is equal to 1 kilowatt hour. Kilowatt means what? Power, and this hour is nothing but what? Time. So 1 unit is nothing but what? 1 kilowatt hour. So energy in kilowatt hour is equal to, energy is nothing but what? Power into time. So power in kilowatts and time in hour. And now we'll start with very important concept, that is nothing but what? Ohm's law. So from Ohm's law we can expect some bits. So what exactly is the Ohm's law? So George Simon Ohm is a scientist. He developed the relation between current and voltage. Uh, so the current I is proportional to V. In Ohm's law, at constant temperature, very important thing is at constant temperature, when the temperature is not changing, current in a circuit is directly proportional to V. So I proportional to V, this I am writing as V proportional to I am removing the proportionality, constant will come. V is equal to Ri. This is the first form of the Ohm's law, and Ri I am writing as IR. V is equal to IR, and we all know current I is equal to dq by dt. So I am replacing current with charge. So V is equal to R dq by dt. This is one more form of Ohm's law. And as V is equal to Ri, from this I want the current value. I is equal to V by R. Very important formula. I is equal to V by R. 1 by resistance. Reciprocal of resistance is nothing but what? Conductance. So V by R, this I am writing as V into G. So I is equal to V into G. G nothing but what? Conductance. So conductance units are nothing but what? Ohm inverse R mho or Siemens. One more unit is nothing but what? Siemens. One small shortcut to remember the Ohm's law formula. So this is called Ohm's law triangle. Now let us say from this triangle you want V value. So I am closing the V. Then I and R both are in the numerator. Both gets multiplied. So V is equal to IR. And I want I value. I have closed the I. So V is in the numerator. R is in the denominator. I is equal to V by R. And here I am closing the R. V is in the numerator. I is in the denominator. R is equal to V by I. So important formulas: V is equal to IR, V is equal to IR, I is equal to V by R is equal to V by I. Now very important thing is, in which cases Ohm's law is going to fail. So what are the limitations of the Ohm's law? Ohm's law is not valid in case of semiconductors. Ohm's law is not valid in case of semiconductors like diodes and transistors. Ohm's law is not valid in case of arc lamps. Ohm's law is not valid in case of electrolytes. Ohm's law is not valid when the temperature is changing. So Ohm's law valid only when the temperature is constant. When the temperature is varying, it's not valid. And whenever current and voltage both are not linearly related, we cannot apply the Ohm's law. So these are the limitations of the Ohm's law. And few more limitations of the Ohm's law are, so Ohm's law is not valid in case of vacuum radio valves and gas filled tubes also. In case of gas filled tubes also, Ohm's law is not going to work. Ohm's law fails at high temperature. At extreme temperature also, Ohm's law is not going to work. And what is the meaning of ohmic material? The material which follows the Ohm's law is known as ohmic material. The materials which does not follow the Ohm's law is known as what? Non-ohmic material. So this is about the Ohm's law. Now we are starting with one more important concept, that is nothing but what? Kirchhoff's laws. So we have Kirchhoff's current law and we have Kirchhoff's voltage law. So let us start with the first Kirchhoff's law, that is KCL. Kirchhoff's, it is also known as Kirchhoff's current law, which deals with the currents, and also known as Kirchhoff's first law. Let us see what exactly is the Kirchhoff's current law. Right from our childhood we are learning about the Kirchhoff's current law. I have taken a node, the point where several elements are connected. At this point you see what are all the entering currents. So I5 is entering, I2 is also entering, and what I1 is also entering. And what are the leaving currents? Let us see what are the leaving currents. Leaving currents are I5, I4 is leaving, I3 is leaving. These are the leaving currents. What Kirchhoff's current law will tell us is, in any lumped electric circuit at any node, sum of entering currents is equal to sum of leaving currents. So entering current sum is equal to leaving current sum. Now see, in this case, what are all the entering currents and their sum? Entering currents is nothing but what? I1, I2, I5. I1 plus I2 plus I5 is equal to I3 plus I4. So sum of entering currents is equal to sum of leaving currents. We all know I is equal to what? What is the formula? dq by dt. So I1 is equal to dq1 by dt. I2 is equal to dq2 by dt. I5 is equal to dq5 by dt. And I3 is dq3 by dt. I4 is dq4 by dt. Now let us apply integration on both on sides. Then this dq1 by dt differentiation gets cancelled. We get q1 plus q2 plus q5 is equal to q3 plus q4. So from this what we can say, sum of entering charges equal to sum of leaving charges. So from this what we can say, KCL follows, very important bit it is, KCL follows conservation of charges. KCL follows conservation of charges. In examination they will ask you KCL follows dash conservation of charges. Now let us understand how to apply the KCL at any particular node with one small simple example. I want to apply the KCL at node A. So first of all I have to identify what are all the currents associated at that particular node, Ix, Iz and Iy. In that what are all the entering currents? Ix is entering current. So sum of entering current is nothing but what? Ix. What are all the leaving currents? Iz is leaving from node A. Iy is also leaving from node A. So leaving current sum is nothing but what? Iy plus Iz. And if I bring these two currents on the left hand side, I'll get as Ix minus Iy minus Iz is equal to 0. You see, entering current is having positive polarity, leaving currents are having the negative polarity. From this what we can say, entering currents and leaving currents will be having the opposite polarity. And here also you see I1 plus I2 plus I1 plus I2 plus I5 is equal to I3 plus I4. If I bring on this side I1 plus I2 plus I5, this I can write as I1 plus I2 plus I5 plus of minus I3 plus of minus I4 is equal to 0. So this we can call it as algebraic sum of current is equal to 0. Algebraic sum of currents is equal to 0. So KCL we can also state as, in a lumped electric circuits at any node algebraic sum of currents is equal to 0. See, KCL is not applicable to distributed circuit. So what do you mean by lumped circuit? In lumped circuit, elements are physically separable. Let us say this is R1 and this is R2 and let us say this is R3. Elements are physically separable. That circuit is nothing but what? Lumped electric circuit. If the elements are physically not separable, that circuit is known as what? Distributed circuit. So in distributed circuit, we cannot identify what are the currents flowing through each element. We cannot apply the KCL. So very important thing, KCL is not applicable in distributed circuits. So let us see few more things related to KCL here. So KCL usage is, we will find out the unknown currents, and advantage of KCL is we can apply the KCL even if the elements of the circuits or network are linear or non-linear, active or passive, or time variant or time invariant. For all the circuit elements the KCL is going to applicable. Linear, non-linear element, active elements, passive elements, time variant element, time invariant element. So KCL is independent of the nature of the elements connected in the node. But the only thing is KCL limitation. What is the drawback of KCL is it cannot be applied in the distributed circuit. KCL is not applicable in the distributed circuits. Not applicable in the distributed circuit. It is very important thing. And as already we have discussed, KCL expresses conservation of charge, and we'll apply the KCL at the node or at the junction. So KCL we apply at node, remember, and we apply KVL in the loop, closed loop or mesh. And entering currents and leaving currents will be having the opposite polarity. And now let us start with the next Kirchhoff's law. Next Kirchhoff's law, that is KCL Kirchhoff's second law, that is Kirchhoff's voltage law. So what is the meaning of KVL? Let us understand by taking one small closed loop. Let us say R1 and R2 and R3 both are, all the three are connected in series with the battery Vs. As Vs is connected, as a power supply is there, closed circuit is there, current will start flowing in the circuit. We assume the current direction from positive terminal to negative terminal. So whenever current flows through the resistor, whenever electrons flows through the resistor, electrons will lose their energy in the resistor in the form of a voltage drop. when current I flows through the R1, there will be a voltage drop V1, and when current flows through R2, there will be a voltage drop V2 and voltage drop V3. Whatever the supply voltage is there, the supply voltage is going to be dropped in the R1 as V1 and V2 and V3. The energy given to the electrons is going to be lost in the R1 and R2 and R3. So according to KVL, in any closed circuit, algebraic sum of voltage is equal to 0. So algebraic sum of branch voltages around any closed path in a circuit is always 0. Okay, so our voltage supply voltage is equal to sum of voltage drops. Now let us apply KVL here. In this particular circuit we will apply KVL. So first of all, while applying the KVL, in which direction you want to apply the KVL, that you identify. In this circuit I am applying the KVL in the current direction. So current direction means current direction is in which direction? Current direction is in the clockwise direction. So I am going to apply the KVL in the clockwise direction. So this applying KVL process is very important in all the circuits analysis. We use this. So I am applying KVL in the clockwise direction. So I am starting from here. So whenever you are going from right to left, you are coming up across a power supply. So power supply voltage is Vs, but you are coming across what terminal first? Negative terminal first. You give the negative polarity to the voltage, and you are coming like this across R1. Across R1, what is the voltage? V1. So I am taking V1. So we are coming across what polarity first? Positive. So to V1 we are giving positive. So algebraic sum of voltages have to take. That's the reason I am considering the polarities of the voltages. All the voltages in the closed loop I am taking, and their polarities also I am taking. So I am coming like this again across R2. What is the voltage? V2. And I am coming across what polarity first? Positive polarity. So plus V2. Again I am coming across R3. What polarity first? Positive polarity. So plus V3 is equal to 0. Total how many voltages are there in the closed loop? Vs, V1, V2, V3. So total 4 voltages. Algebraic sum of voltage is equal to 0. So this minus becomes plus Vs. Vs is equal to V1 plus V2 plus V3. We all know that electric potential V is equal to W by Q. So you see in the circuit, same current is flowing through R1, same current is flowing through R2, same current is flowing through I. So as the current is same, the charge is going to be same. So here you see that as the current is same, the charge Q, V1 W1 by Q, V2 W2 by Q, V3 W3 by Q. In whole equation we can take 1 by Q as common, and then that 1 by Q gets cancelled, and we'll get as W is equal to W1 plus W2 plus W3. It shows KVL follows conservation of energy. KVL is following what? Conservation of energy. It's very important. Very important bit. KVL follows conservation of energy. Again, let us take one more simple circuit to apply the KVL. I told you we have to identify in which direction we have to apply the KVL. In this circuit, the current is flowing from clockwise direction. Therefore, I am going to apply the KVL in the clockwise direction. So when I am coming here first, what is coming? Vs is coming, and I am coming across what polarity first? Minus. So minus Vs. So I am coming like this, and the voltage across R1 is nothing but what? V1, and I am coming across what polarity first? Positive. So plus V1. And I am coming across R3. What is the voltage? Sorry, R2. What is the voltage across R2? V2. I am coming across what polarity first? Positive polarity. So plus V2. So Vs equal to V1 plus V2. And voltage across R1, according to Ohm's law, V is equal to what? IR. I means current flowing through R1 is what? Is, and resistance is nothing but what? R1. And V2 is equal to current flowing through R2 is what? Is into R2. V2 is equal to Is into R2. So what is the advantage of KVL? The advantage of KVL is again, it is independent of the nature of elements in the loop. So KVL cannot be applied in distributed circuit, same thing. So we cannot find out voltage across each individual element. So it is not possible to separate the elements physically in the distributed circuit. So it is not possible to apply the KVL in the distributed circuits. And KVL is used to find out the unknown voltages. And as we told, KVL expresses conservation of energy, and KVL is applied in the loop or KVL is applied in the mesh. Whereas KCL follows conservation of charge, KCL is applied at the node or junction. Now we'll come across one more important concept, that is basic circuit components, and here we'll discuss about resistor, inductor, capacitor. So let us start with the first element, that is resistor. So resistor we represent like this zigzag symbol. And what is the resistance? Resistance R is nothing but it is the ability of the material to oppose the flow of current. So resistance is nothing but what it is the ability of the material to restrict or oppose the flow of electrons. Flow of current is known as what? Resistance. Resistance depends upon the length of the conductor. Resistance depends upon the area, cross-sectional area of the conductor, and resistance depends upon the length of the conductor, directly proportional to the length and inversely proportional to the cross-sectional area. So R proportional to L into 1 by A, that is L by A. So if I remove the proportionality, we'll get the proportionality constant, that is rho L by A. R is equal to rho L by A. It is very important formula. R is equal to rho L by A. Rho is nothing but what? Resistivity of the material, length of the material, cross-sectional area of the material. So from this formula R is equal to rho L by A, we get the rho formula as RA by L. R resistance units are nothing but what? Ohm, cross sectional area meter square, length meter. Then we'll get the unit of resistivity is ohm meter. This is also one of the important bit. Resistivity units is nothing but what? Ohm meter. And current through the resistor is I is equal to V by R. We know according to Ohm's law, V is equal to what? IR. And from this, I is equal to what? I is equal to V by R. And what is the power loss in the resistor? We know power loss formula is nothing but what? P is equal to what? VI. So again V into I is equal to what? V by R. So it becomes what? V square by R. And also it becomes what? I square R. So energy lost in the resistor is what? Energy is equal to integration power with respect to time. So 0 to t p dt. And reciprocal of resistance is known as what? Conductance. And conductance units are nothing but what? Mho or ohm inverse or Siemens. And this formula is very important. R is equal to rho L by A. And resistance units are nothing but what? Ohm. And conductance G is equal to what? Conductance G is equal to 1 by R, and then we will get conductivity as GL by A. And now let us see characteristics of resistors. What is the voltage current characteristics of resistor? As we know, as the voltage increases, current is going to increase. So there is a linear relationship between voltage and current in case of resistor. So we will get linear characteristics. And the slope of this curve is nothing but what? Y-axis value by x-axis value, that is V by I. So plus V by plus I or minus V by minus I, then we will get the slope positive. Slope positive is nothing but what? Opposition to the flow of energy, that is passive element. So resistor is a passive element. Now let us see, in case of insulators, in case of electrolytes, in case of semiconductors, how the resistance value changes with respect to the temperature. As the temperature changes, the conductance is going to increase, that means resistance is going to decrease. That's the reason we call as insulators, electrolytes and semiconductors will have negative temperature coefficient. So as the temperature is increasing, resistance is decreasing, means that elements will be having the negative temperature coefficient. In case of metals, as the temperature increases, resistance is going to increase. So metals will have positive temperature coefficient. And now we'll see second important circuit component, that is nothing but what inductor. Inductor nothing but one small wire have taken, that wire have twisted into some turns, then inductor is formed. So this is nothing but what inductor. The property of the inductor is it opposes the sudden changes in current. Opposes the sudden changes in current. This is the property of the inductor, sudden changes in current. So inductor is a two-terminal device and it stores the energy in the magnetic field. When current flows through this coil, the magnetic field will be developed. In this magnetic field, the energy is going to be stored. So inductance we denote with L. And now let us see what is the voltage across inductor and what is the current through the inductor, what is the energy stored in the inductor. Let us determine, and what is the inductance value. So we know that when any current flows through any coil, flux gets developed, and if that flux is alternating flux and then EMF is induced, and according to Faraday law, V is equal to E is equal to N into d pi by dt. And is the number of, if the number of turns are fixed and EMF induced in the coil is directly proportional to the rate of change of flux. More rate of change of flux, more EMF. Less rate of change of flux, less EMF. So EMF induced in an inductor or coil directly proportional to the rate of change of flux, E proportional to d pi by dt. But we know flux is proportional to current. More current, more flux. D pi by dt nothing but what? Di by dt. And if I remove the proportionality, we'll get one constant, that is nothing but what? Inductance. So voltage across inductor is equal to L is equal to di by dt. Voltage across inductor, what is the formula? Very important, L into di by dt. And pure inductor means whatever the coil, whatever the conductor we are using, it has no internal resistance. Internal resistance of the inductor is 0. This is pure inductor. And but in practice, that coil will have some internal resistance. So practical inductor we denote like this, with some internal resistance. Now let us determine inductance of an inductor. So we know flux directly proportional to the current, and flux linkage n pi proportional to the current. So n pi, if I remove the proportionality, we will get the constant L. So from this L value is equal to n pi by I. Very important formula, inductance L is equal to, what is the formula? N pi by I. This n pi is known as flux linkage psi. So L is equal to n pi by I. Now let us see characteristics of inductor. On x-axis I have taken the current, on y-axis I have taken the flux linkage. So you see, as the current increases, flux developed in the inductor is going to increase, and flux linkages is going to increase. So we have a linear relationship between current and flux linkage. As the current is increasing, psi flux linkage is also increasing, we will get the linear curve. And the slope of this curve is positive. Slope of this curve is y-axis value divided by x-axis value. Y-axis value is psi, x-axis value is I. Psi by I is known as what? Inductance L. From this you see psi by I is known as what? Inductance L. And important formulas with respect to inductor, V is equal to L di by dt, and current through inductor is equal to 1 by L integration V dt. And very very important formula, energy stored in the inductor is equal to half VLI square. Now let us see what happens if DC supply is given to the inductor. Whenever DC supply is given to the inductor, what is going to happen? We know voltage across inductor L is equal to di by dt. As the applied voltage is DC, current flowing through inductor is also DC, then this current I is DC current. DC current is nothing but what? Constant current. So differentiation of constant is what? 0. So L into 0, that is 0. So voltage across inductor becomes 0. That means inductor acts as a short circuit. So whenever DC power supply is given to the inductor, inductor acts as a short circuit. Now let us see about the capacitor. About the capacitor we'll see now. Capacitor is nothing but it's a two terminal device and two conducting plates. Let us say it is plate A and it is plate B. Two conducting plates separated by some insulating material or dielectric material. This is known as what? Capacitor. So capacitor is capable of storing the energy in its dielectric field. Inductor stores the energy in the magnetic field, inductor, and capacitor stores the energy in the electric field. So what is the charge accumulated on the capacitor plates? Charge accumulated on the capacitor plates is directly proportional to the applied voltage. So Q is equal to, we will get CV. So capacitance C is equal to Q divided by V. Very important formula. C is equal to Q by V. Now I want to find out the current through the capacitor. That is current through the capacitor I. We know current is equal to, what is the current formula? I is equal to rate of change of charge, dq by dt. So d by dt of charge. So from this formula, charge q is equal to, what is the value? CV. So IC, current through the inductor, is equal to rate of change of charge, rate of change of CV. So C is a constant. It comes outside, C into dV by dt. Important formula, current through the capacitor, I is equal to C dV by dt. Current through the capacitor formula, I is equal to C dV by dt. And from this formula, you can calculate V value, that is V is equal to 1 by C integration IC dt. And what is the energy stored in the capacitor? Half CV square. Very important formula. Energy stored in the capacitor is what? Half CV square. And now let us see what happens if DC power supply is given to the capacitor. So we know current through the capacitor formula is I. I is equal to C dV by dt. DC power supply means this V becomes constant. So C into d by dt of constant. Differentiation of constant is equal to what? 0. Current becomes 0. Current 0 means open circuit. Whenever DC power supply is given to the capacitor, whenever DC power supply is given to the capacitor, and it becomes open circuit. Now let us see characteristics of capacitor. If applied voltage to the capacitor increases, then charge accumulated on the capacitor is going to increase. So as the voltage increases, charge accumulated on the capacitor increases. So on y-axis I have taken charge, on x-axis I have taken applied voltage. As there is a linear relationship between voltage and charge, so we have linear relationship. And what is the slope of this curve? Slope of curve means y-axis value q divided by x-axis value v. So that becomes what? Capacitance. Slope of this curve is capacitance. This is plus c, and here also in the negative axis also we will get minus q by minus v. That is nothing, minus minus cancel, we will get c. So slope positive means capacitor is also passive element. Inductor also passive element, capacitor also passive element. But inductor stores the energy, capacitor stores the energy. Even though they stores the energy, but they are not active element, they are passive element, because they cannot deliver the energy continuously. If the capacitor charging is completed, they cannot deliver the energy. Inductors charging is completed, they cannot deliver the energy. They cannot deliver the energy continuously over an infinite time period. So they are passive elements. So this is characteristics of capacitor. Now we'll start with that is energy source. Energy sources. All the energy sources are classified into two types, that is independent energy source and dependent energy sources. Again, in independent energy sources we have ideal energy sources and we have practical sources. And here let us see, in ideal sources we have ideal voltage source and we have ideal current source. In practical sources we have practical current source and we have practical voltage source. and in dependent sources, dependent sources means it may be dependent voltage source or dependent current source whose voltage or current depends upon some other voltage or current in the circuit. So we have, these are all different dependent voltage sources. We'll discuss about the energy sources now. Now we'll start with the independent energy sources. In that, ideal sources, first one is ideal voltage source, and it is also known as constant voltage source. So ideal voltage source voltage value does not depend upon the load. Ideal voltage source voltage Vs is completely independent of the current flowing through its terminals. So that means what? Whatever may be the current flowing through its terminals, there won't be change in the voltage source voltage value. So this is nothing but what? Ideal voltage source. So ideal voltage source will be representing like this. So ideal voltage source with positive terminal, negative terminal, and there is no internal resistance. Ideal voltage source internal resistance is equal to 0. Now let us say load is connected. Vs of t is the supply voltage, and it is delivering the current Is of t, and voltage across the load is what? Vt of t. And as there is no internal resistance, whatever the voltage source voltage value is there, that entirely appears across the load. So what we can say, voltage across the load Vt of t is equal to applied voltage Vs of t. It is nothing but what? Ideal voltage source. Whatever may be the load current, whatever may be the terminal current, there is no change in the Vs value, there is no change in the Vt value. And if I apply the KVL to know the relation between Vs and Vt, I am applying the KVL in this direction. I am coming across a negative polarity first, therefore minus Vs of t. There is no voltage drop in the line, and I am coming across positive polarity first, so plus Vt of t is equal to 0. So Vs of t is equal to Vt of t. Our terminal voltage is equal to terminal voltage equal to what? Source voltage. So here one important statement, ideal voltage source internal resistance is 0. As the ideal voltage source internal resistance is 0, voltage source voltage value, total voltage is going to appear across the load. There is no loss of the voltage in the internal resistance, because internal resistance is 0. R is 0 means voltage drop in the internal resistance is 0. So entire source voltage will be given to the load. That's the reason it is known as what? Ideal, no loss, ideal voltage source. Ideal voltage source internal resistance is it is 0. Now let us see VI characteristics of ideal voltage source. So whatever may be the source current, there is no change in the terminal voltage. Always terminal voltage equal to what? Supply voltage. So this is that's the reason it is known as what? Constant voltage source. Or it is output voltage, terminal voltage is independent, therefore it is known as what? Independent source. Vt value does not depend upon the load current or Is. So it is known as what? Ideal voltage source or independent voltage source. Now here you see ideal voltage source. Here source is delivering the current. This we say source is delivering. As the current is going out of the positive terminal, we say source is delivering the current, delivering the power. Or here you see current is entering through the positive terminal, source is charging or battery is charging. So what are the example for ideal voltage source? Are some storage batteries. We have storage batteries, and we have generators, and we have dry cells. These are known as what? Ideal voltage sources. And now let us see ideal current source. See, this is ideal current source. We represent the current with arrow symbol, and as it is ideal, we represent with circle. This is ideal current source, and it is connected to the load. Let us say it is connected to the load. Is of t is connected to the load, and whatever the current given by the source that is completely going into the load. So there is no division of current, there is no loss of current. That means ideal current source internal resistance is infinity. You see, internal resistance we represent in the parallel connection, but here no current is flowing, entire its current is going through the load only. This resistance is huge, infinite. That is the reason there is no current flowing through the internal resistance, entire current will go through the load. So ideal current source internal resistance is what? Infinite. So total source current will go through the load only. So voltage across the load, if I take as Vt or Vs, so this current flowing through the load is independent of load voltage. You see here VI characteristics. So load current is constant whatever may be the voltage across the load. And that we have completed ideal sources, ideal voltage source and ideal current source. And we have practical voltage source, also known as real voltage source, also known as non-ideal source. That means entire voltage source voltage value is not going to be given to the load. This is known as practical voltage source. It has some voltage drop, it has some internal resistance. Let us say out of 10 volts, 2 volts is wasted as voltage drop in the internal resistance, remaining 8 volts is given to the load. So there is some voltage drop in the internal resistance. Now as current changes, voltage drop is also going to change. So this is known as what? Practical voltage source. We represent the practical voltage source with the voltage source voltage value in series with the internal resistance. Why in series? Whenever we represent resistance in series, then only we represent some voltage drop. And let us see, now I have connected the load. Let us apply the KVL. This is a source current. I am applying the KVL in the clockwise direction. I am starting from here. I am coming across a negative polarity first, therefore minus Vs is coming, and I am coming across positive polarity. Voltage drop across any resistance is I into R, that is Is into Rs, plus Is into Rs, and voltage across the load is Vt. I am coming across positive terminal first, so plus Vt is equal to 0. Then I want voltage across the load. Voltage across the load is what? Vt is equal to Vs minus Is into Rs. So you see, voltage across the load value is going to change with respect to the current flowing through the load. If current flowing through the load is increases, then voltage drop in the internal resistance is going to increase. Then voltage drop in the internal resistance increases means net voltage given to the load is going to decrease. You see, Vs minus Is Rs, net voltage is going to decrease. More current flowing through the internal resistance, more voltage. Out of this 10 volts, more voltage up here, less voltage is given to the load. So the same thing we can see in the VI characteristics over here. You see the VI characteristics, as the current increases, you see net voltage across the load is going to decrease. This decrement is due to what? Voltage drop across the internal resistance. As the current increases, terminal voltage, output voltage across the load is going to decrease. That is about the ideal voltage source. Now let us see practical, that was practical voltage source, and it is now practical current source. So what is my meaning of practical current source is, whatever the source current is there, this entire source current is not going through the load. Entire current is not going through the load. Some current is going through the internal resistance. That current division I have to show means I have to connect the internal resistance in parallel connection. So this is a representation of practical current source. So total current is not going through the load. Some current is dividing. That current division I have to represent means I have to connect the internal resistance in parallel. So what is the definition of the practical current source? In practical current source, the resistance is in parallel with the source. In this, magnitude of the current falls as the voltage across its terminal is going to increase. If I connect the load, voltage across the load increases means current flowing through the load is going to decrease. That we'll see now. So this is a practical current source. Current delivered by the source is Is. Current flowing through the internal resistance is IR. Current flowing through the load is IT. and voltage across the load is nothing but what? Vt. I am applying KCL at this particular node A. Sum of entering currents is equal to what? Sum of leaving current. What is the entering current here? Is. Is the entering current. What are the leaving currents? Ir is leaving, il is leaving. Ir plus it. It means load current or terminal current. So but I want this it value, that is is minus ir. And what is the IR value? According to Ohm's law, I is equal to what? V by R. Now I want IR value. So IR value means voltage across this resistor is equal to voltage across load, because in parallel connection voltage is same. So what is the voltage? Vt. Vt divided by what? Rs. So load current IL is equal to Is minus Vt by Rs. As a terminal voltage increases, this value is going to increase. Then total current is going to what? Decrease. You see, you will understand here clearly. As the terminal voltage increases, Vt by Rs is going to increase, but the subtracting value is increasing, means total value is going to decrease. This total value is nothing but what? Load current. It value is going to decrease. So current delivered to the load is a function of load voltage. Current delivered to the load, this it is this it value is a function of the load voltage Vt. So this is about ideal voltage source and practical voltage source. Ideal voltage source, practical voltage source, ideal current source, practical current source. Very important conclusions are: ideal voltage source internal resistance is 0, ideal current source internal resistance is infinite. Now let us start with the dependent sources. Dependent sources means whose voltage or current depends upon some other voltage or current in the circuit. They are not independent, they are dependent on some other factors. These are also called as controlled sources. Dependent sources also called as what? Controlled sources. In dependent voltage source, we have different types. So first, dependent voltage source. Let us say dependent voltage source voltage value depending upon some other voltage. Voltage source voltage value controlled by some other voltage, that is called voltage dependent voltage source or voltage controlled voltage source. And second one is voltage source voltage value depends upon some other current. So that is called current dependent voltage source or current controlled voltage source. Voltage source voltage value depending upon some other current. And now dependent current sources. Dependent current source means current source current value is a function of some other voltage or some other current. If the current source current value depending upon some other current, that is known as current dependent current source, or it is also called as current controlled current source. And current source current value is a function of some other voltage in the circuit. That means voltage dependent current source or voltage controlled current source. Then how to construct these dependent sources? This dependent source is a 4 terminal element. These are the 2 terminals and these are the 2 terminals. So current 4 terminal time invariant element, and these sources are symbolically represented in a diamond shape to show it is a dependent, and their source may be either current or voltage. So I am representing the 2 branches. This is branch 1 and it is branch 2, having 2 branches, where branch 2 is either voltage source or current source. Branch 1 is either open circuit or short circuit. Let us say I want to represent dependent voltage source. Then what I have to do? Branch 2 must be, it is a voltage source, means I have to represent as a voltage source plus minus. And branch 1 must be either open circuit or short circuit. So again I'll explain. This dependent sources, how to construct means it has 2 branches. So this is branch 1 and it is branch 2. So branch 2 represent whether it is a voltage source or current source. Branch 1 represents either open circuit or short circuit. Either open circuit or short circuit. Let us say I want to show voltage controlled voltage source. Voltage controlled voltage source. First of all, what it is a voltage source. So branch 2 we have to represent as a voltage source. Diamond symbol. Voltage means plus minus potentials, plus minus. So it is a voltage source. And voltage source, voltage value depend upon what? Other voltage. Voltage controlled voltage source. Voltage source voltage value depends upon some other voltage, means voltage I have to represent in the branch 1. If I represent short circuit, then voltage becomes 0. No, it's not correct. I have to represent voltage with what? Open circuit. So open circuit, with open circuit I have to represent the voltage. So this is voltage controlled voltage source. Let us see all the different voltage sources. So first one I am starting independent voltage sources, that is voltage dependent voltage source, voltage controlled voltage source. So first of all, it is a voltage source whose voltage value depending upon some other voltage. So how to construct the diagram? I have told you two branches will be there. So two branches. Branch 2 must be either voltage source or current source, as it is a voltage source. So here I have represented with a diamond symbol and plus sign minus. It is a voltage source. And this voltage source voltage value depending upon some other voltage. Branch 1 I have to represent voltage. Voltage means what? Open circuit. That's the reason you see this is open circuit. And this open circuit voltage is what? V1. That means this voltage source voltage value depending upon some other voltage that I am representing here. This voltage source voltage value V2 is depending upon some other voltage. What is some other voltage? Branch 1 voltage. But that some other constant I am assuming as X into V1. So V2 is equal to X into V1. X is equal to V2 by V1. So this is known as voltage gain. So AV means voltage gain. So V2 is equal to what I have got here? AV into V1. This voltage source voltage value is nothing but what? AV into V1. Next, here we will see second type of dependent voltage source whose voltage value depending upon some other current. Now current dependent voltage source. So current dependent voltage source. So branch 2 nothing but what? Voltage source. I have represented voltage. Branch 1 nothing but what? Either open circuit or short circuit. Here branch 1 I have to represent current. In open circuit current will not be there. So branch 1 I have to represent means I have to represent current. I have to represent current means I have to represent with a short circuit. Therefore I have represented with short circuit, that is I1. So voltage source voltage value depending upon branch 1 current, that is I1. Therefore I am writing as what? Voltage source voltage value depending upon branch 1 current I1. So this X value I want, that X or K value is equal to V2 divided by I1. So V2 by I1, V by I nothing but what? Resistance, that is RM. We call this as a trans resistance because it is a transfer resistance, relation between output voltage and input current. So what is this? What exactly it represents? Voltage source voltage value depending upon some other current. So it is a current dependent voltage source. Now we'll discuss about the dependent current sources. In dependent current sources, we have two types of dependent current sources: current dependent current source, voltage dependent current source. So first one is current source current value depending upon some other current. So branch 2 must be what? Current source. So I have represented with diamond symbol to show dependent source. Current value means what? Arrow. So branch 2 is a current source, but that current source current value depends upon what? Current. So branch 1 must be current. So branch 1 must be current means I have to represent with what? Short circuit. So therefore I got, so branch 2 current depending upon branch 1 current. So X is equal to what is the formula? I2 divided by I1. So this is known as what? Current gain. So AI I am writing. So current source current value I2 is going to depend upon current, other current value. Dependent current source current value depending upon other current. That's the reason it is known as dependent current source. Now let us see second dependent current source, that is voltage dependent current source. Let us see. So voltage dependent current source. So branch 2 must be what? Current source. Therefore I have represented branch 2 as a current source, and branch 1 must be voltage. Voltage means I have to represent as what? Open circuit. So in this manner, you remember, open circuit, what will exist? Voltage will exist. So this is the branch 2 current. So branch 2 current depending upon some other branch 1, some other voltage, that is branch 1. X is equal to I2 by V1. I by V means, V by I means resistance, I by V means reciprocal of resistance, that is conductance. So X is equal to what? Gm. So I2 current source current value is equal to Gm into V1. You see, this is the uh, voltage dependent current source. Current source current value, current source current value, current source current value depending upon some other voltage. That branch 1 voltage changes means current source current value changing. Current source current value is controlled by some other voltage. So it is called voltage dependent current source or voltage controlled current source. Now let us see, whenever we are working with the circuits, we may be comfortable having voltage source in the circuit. Sometimes we may be comfortable having current source in the circuit. Then how to change, how to transform voltage source into current source or current source into voltage source? This is known as source conversion or source transformation. Let us see how to convert voltage source into current source. First, ideal voltage source into ideal current source. You see here, voltage source voltage value is Vs and its internal resistance is Rs. It is a practical voltage source, and now this I want to convert into current source. So we know current source means current source value is in parallel with the internal resistance. Here whatever may the internal resistance is there, same internal resistance will come in parallel. Now current source current value I want. According to Ohm's law, I is equal to, what is the formula? V by R. V nothing but voltage source voltage value, that is Vs, and internal resistance R nothing but what? Rs. So Vs and Rs given, I found out Is value as well as Rs, same internal resistance of the voltage source will come in parallel with the current source value Rs. This is called converting voltage source into current source or source transformation. Now let us see, here you see again the same thing. This current value I is equal to V by R. The same R will come over here, but one small difference over here. You see how to represent this current direction. It is very important how to represent this current direction, upwards or downwards, how to decide. You see here, current I am assuming as from positive terminal to negative terminal. Now it came what? Upwards direction, therefore I kept upward direction. That means this arrow direction should be on the positive terminal side. We will see in the next diagram. You see here, positive terminal to negative terminal, current direction is downwards. Current direction is downwards. Next we will see conversion of current source into voltage source. So this is a current source in parallel with the internal resistance, but we know in voltage source is going to be series with the internal resistance. The same internal resistance will come here, and voltage value according to Ohm's law, V is equal to what? IR, but I is equal to Is here and R is equal to Rs here. Here I am writing Is into Rs. You see current direction is upwards, so on the top we will get the positive terminal. And next we will see one more current source. Current direction is downwards, we will get the positive terminal downwards, and same internal resistance will come in series here, and the voltage source voltage value is current value into resistance. V is equal to IR. Now we'll start with one more important topic, that is types of elements. So what are the different types of elements we have? We have different types of elements like, let us see quickly, we'll complete these types of elements: active elements and passive elements. The elements which can deliver the energy are known as active elements. The elements which cannot deliver the energy continuously are known as passive elements. And unilateral elements and bilateral element, the elements which offers the different impedances for the different directions of the current is known as unilateral element. And the elements which offer the same amount of impedance for both the directions of the input voltage or current known as bilateral element. The elements in which whose voltage current relationship is linear element. The element whose voltage current relationship is not linear, that is non-linear element. The elements which are physically separable in a circuit is called lumped elements. The elements which are not physically separable known as what distributed elements. The element whose voltage current characteristics changes with the time variant element. Whose value does not vary with the time invariant element. This is about the types of element. Let us discuss in detail about the types of element. Active element. So energy sources are called active element, or an element which can deliver the energy continuously known as what? Active element. So example, voltage sources, current sources, generators or transistors are example for active elements. Now passive elements, you all know inductor can store the energy, capacitor can store the energy, they can deliver the energy but they cannot deliver the energy continuously. They cannot deliver the energy continuously, therefore they are known as what? Passive element. The elements which are not energy sources, the elements which are capable of receiving energy only, which are capable of not delivering the energy, known as passive element. They are capable of only absorbing the energy. So like resistor, inductor, capacitor, transformers, all these are example for passive elements. And let us see about the unilateral element and bilateral element. The element which have different voltage current relationship for either direction of the current flow are called passive elements. That means if the input supply polarity changes, element voltage current relationship is changing and element impedance is changing, then that is known as what? Unilateral element. You see the elements which offer the low impedance for flow of current in one direction and high impedance for the flow of current in the other direction. Elements are offering different impedances for the different flow of current. That is nothing but what? Unilateral element. They, you see one example, I have taken the diode. Now it is in forward bias. Positive terminal is connected to anode and negative terminal is connected to cathode. It is in forward bias. It is conducting and impedance of the diode to the flow of current is 0. But the same element just have reversed the input supply polarities. Then you see negative is connected to positive, positive is connected to negative. Now it is not allowing the flow of current. That means here it is allowing the flow of current, here it is not allowing the flow of current. That means the element which allows the flow of current in only one direction is also called as unilateral element. Here impedance is 0, but here current is not flowing, means open circuit. Impedance is what? Infinite. Element is offering 0 impedance here infinite impedance for the different input polarity of the supply voltage. This is known as what? Unilateral element. So diode is example for unilateral element. Bilateral element means voltage current relationship is linear and voltage current relationship is not changing with respect to the time or input power supply polarity, that are known as what? Bilateral element. They allows the flow of current in both the directions. Example, resistors are example for bilateral element. And linear element, voltage current relationship is linear, that elements are linear element. You see in case of inductor, not iron core inductor, in case of air core inductor, voltage current relationship is linear. And non-linear element, example diode, in case of diode voltage current relationship is not linear, therefore it is example for non-linear element. Iron core inductor also voltage current relationship is not linear. Lumped elements, in the circuit if the elements are physically separable, those elements are lumped elements. Example, resistor, inductor, capacitor, those are lumped elements. Now distributed element means if I take transmission line, if I take the transmission line, it has resistance, inductance, capacitance distributed across entire line. So where is resistance, where is inductance, where is capacitance, we cannot separate physically. It is distributed throughout the line along its length. So transmission lines are example for what? Distributed elements. And time variant element, if the parameter of the network is not varying with respect to the time invariant element, if the parameter of the element is changing with respect to the time, it is called time invariant element. So what exactly we have discussed? Quick conclusion of the video is, so we have discussed about the what is current, what is voltage, what is potential, what is power, what is energy, and what is Ohm's law we have discussed, what is KCL and what is KVL, and how to apply the KVL in a circuit, how to apply the KCL in a circuit we have discussed, and what are the limitations of Ohm's law, KCL, KVL we have discussed, and we also have discussed energy sources, independent energy sources, dependent energy sources, ideal voltage sources, ideal energy sources, practical energy sources, ideal and practical, and we have discussed about the dependent sources, and we have discussed about the types of elements, and we also have discussed about basic circuit components, resistor, inductor and capacitor, and resistor, inductor, capacitor are passive elements, and what is the voltage across inductor, what is the current through the capacitor, what is the energy stored in the inductor, what is the energy stored in the capacitor, all basics we have discussed in this video. As it is a first video, basic video, I have spent little more time on discussing the basic concepts. In the next video I'll discuss the bits on all these concepts, practice bits and previous questions on this particular concepts. Thank you. Your feedback, you can post your comments in the you can post the comments. Accordingly we'll design the next videos. In next 4-5 videos, entire basic electrical engineering concept will be completed along with the concept as well as bits. Post your comments.